All right, the recording is on. May I ask those of us that are here this morning, from what we have done till now, do you have any question? If you have any question, please let's ask questions. If you have any trouble, I'll be glad to hear the trouble so that we see how we can help ourselves. Don't consider the trouble you have as too significant, and don't also consider the trouble you have as insignificant. In a classroom of discussion where logic arises, there is no small problem, there is no bigger one. Every problem should be shared by those involved. So, the floor is open. If you have any challenge, please do come up now.
Good morning, sir.
Good morning, madam.
Mr. Labini on the line, sir.
I know.
Just like you have told us that we should not fear. We have created a kind of one-on-one social rapport
Yes.
so that we can express our mind so as to help us.
That's good.
Sir, every other thing,
Are you still with us?
thank God for all the lectures and everything that you have really opened our eyes to.
Okay.
This statistic, we love it. I love it. But the only area that I have problem is the area of comparing means. I tried everything, the basic report, although I tried reading and I didn't get it.
Okay.
I've done it to the extent of the sex, athletes, sprints. Then the area of you can also drag the items within the cell statistic board to change the order that the statistics are displayed in the output. I tried doing it, I click OK, but my result was no cases were input to this procedure. Either there are none in the working data file, or
Okay.
all of them have been filtered out. That was the result I got.
Okay.
So I didn't really get it, and I've been trying to get my colleagues, and everybody is having one challenge or the other. So I said, now that you have spoken well this morning, sir, I said, let me come out and not be ashamed.
Please don't be.
Thank you, sir.
Even if I have not spoken, most of the times I wish I would, and the time is not there. So even if at least you know me as a teacher, you know what my capabilities are, you know my limitations also. Time could be part of those limitations. When you don't speak doesn't mean that you don't have the facilities. So please don't be afraid of speaking out. All right. I think what we will do when you come to school next week, show me what you have as a challenge. Would that be okay?
Okay. Yes, sir, that will be okay, sir. Thank you, sir.
We can discuss outside the classroom in my office
It's okay.
so that we see
It's
this.
okay, sir.
And
Thank you.
for other people too who are in the same similar challenges, it may not be compare means, it may be other. Please don't be afraid to speak out. Apart from the fact that I'm most interested in you benefiting from your investment, I'm also very much interested in you benefiting from the intention of why you have registered for this course, so that you'll be happy at the end of the day. Okay, thank you so much. So with that, I want us to begin the class. If there are other issues, please don't hesitate to reach out to me either privately or on a group WhatsApp that we have. So today we are going to look into multiple linear regression. I forwarded the note earlier this morning, as early as I could, and I also forwarded the SAV, the data set that we'll be using. So permit us, let's go through this theory very well. Once we can understand this theory, the practical application will be very easy too. Now, when we talk about multiple regression, let's look at this example and see how we can work with this. Other examples will come forward. May I ask, can you see my screen? No.
No, sir.
Oh, sorry.
sir.
All right, let me share my screen. All right, just a minute. Okay, can you see my screen now?
Yes, sir.
Okay. Sorry, thank you.
Yes, sir. You can see it.
Please always talk. If I had not noticed that, I'm not sure if I've shared it. Always, please always discuss in class. Talk to me. Okay, talk to me. There are times you think you have done all that you should do, and you won't know until the student speaks out. So please always speak when you need to speak. Multiple regression. Let's look at this. When we talk about multiple regression, do you still remember our dependent and independent variable class? I want us to talk.
Yes, sir.
Okay. Now you remember, class, that our dependent variable is the result that we want to show, is the result that we want to display. The independent variable is the variable that manipulates the result, that will change the result. Do you still remember that?
Yes, sir.
Okay, now let's look at this example. A scientist wants to know if and how health care cost. When we talk about care of health cost, which means how much do you pay for certain costs in the hospital when you go there. So a scientist wants to know if and how healthcare costs can be predicted from several patient characteristics. Okay? Now, what are these characteristics? Let's see some of these characteristics as we have them there. If you look at the name under this window, I have ID, I have service date, I have region, I have sex, I have age, I have marital status, I have alcohol, I have cigarette, I have exercise, and finally I have cost. Now, the cost here, which is number 10 here, is the dependent variable. The rest are actually independent variable. If you look at what I try to do for us, I say, okay, independent variables are age, sex, drinking, smoking, and exercise, while the dependent variable is health cost. We're now saying that if the sex of patient change, will the cost of the patient health change? I'm asking you, class. That's what we that's what we mean by the multiple regression. You can't say no. You can't say no. You don't know. Okay, it's something I don't know either. If you are a male, maybe they don't fall sick. Maybe they fall sick twice in a year. While female, probably fall sick 5 times, 6, 7 times in a year. We don't know. It's not something that we can predict without getting the data. That's what we want to know. What about age? At what age do you spend more on what? On the cost of health. Okay, what of those who are drinking? What of those who are smoking? What of those who are in exercise, who do exercise every morning, carry out exercise? So as a matter of fact, if you look at 1, 2, 3, 4, and 5, I have 5 independent variables here. We are saying that all this will what? We determine the cost of what? Health. Do you believe in that, everybody?
Absolutely, sir. Yes.
Good.
Yes,
Now the costs, the manipulation, the changes in the cost is what we don't know. How, at what level will the cost be high or low? We don't know, and that is what we want to find out. Will it be so high? Will it be so expensive for someone at an older age, or someone at a very tender age? What is the difference between the cost of what? Hospital cost. When you drink, when you don't drink, when you exercise, when you don't exercise. That's what we want to get here. So it's possible, and when we say multiple regression, meaning that we have one more than one independent variable. Okay? The moment you have more than one, then you are talking about more than linear. It's no longer linear. If it's linear, then you are talking about one to one. Then you can talk about ANOVA that we have been using before. But the moment you are talking about sex age, more than two here, then you are talking about what? Multiple regression. No longer linear regression. Mathematically, linear regression is just A plus B plus C, meaning that we have just how many? We have just one what? One independent variable and one dependent variable. But the moment you have more than one dependent variable, more than one independent variable, then you are talking about multiple regression. And that's why we talk about age, sex, drinking, smoking, and what? And exercise. May I ask if this explanation is clear to everyone? Hello?
Yes, sir.
Okay, now let me show you a bit of the data. There's an assumption that we must make, but before we make the assumption, I like to share the knowledge of the data with you briefly, then I will come back to the theory. Like I said this morning, the topic we have this morning is very simple but logical. Very simple but logical. So we need to understand it very, very well. So this is the data set where I have the variable name, and it's just about 10 variable. And let's look at the data view. Data view here, we have so many of them. Okay, how many now? 525 in number. 525. May I ask you few questions? What did you notice in this data? By the way, can you see the screen?
Yes, sir.
What did you notice? What can you notice in this data set? Just tell me your observation based on what you can see. I'm particularly interested in outliers and empty field.
There is no missing the data, sir.
Okay. Of course, you can't know outliers. Even if they are outliers, you cannot know, except we run a data, we run a analysis. Do you know that?
Yes, sir.
All right. By the way, I just thought of it sometimes during the week. By now, you should know how to run your Cronbach alpha for reliability of a variable. Do you want me to repeat that again?
Yes, sir.
When you are running, those of you who are on your PhD, I won't teach you, but I want you to go and learn it. It's not that I can't teach you. It's just two buttons is what you need to know. Two buttons. When you are running your PhD, you write your proposal. When you write your proposal, they will tell you to go and validate your what? Your instrument. Please go and learn how to validate it. It's the easiest work. It's something within two buttons. If you don't know what to do, just ask YouTube, how do I validate? How do I run what? Cronbach alpha on my what? On my instrument. It's going to teach you. Right? I just thought of it that by now you should know it. But in case you don't know it, please learn it. So that will be an additional, some of the money you are supposed to throw away at your PhD. It's not a big deal. Within 2 minutes, you run it and you interpret it. Then you can present it alongside your proposal. Are we together, class?
Yes, sir.
It's called Cronbach alpha. There are so many methods, but one of these statistical means is that you run a Cronbach alpha. Learn it is under analysis, just two buttons, and you can learn it and contact me to be sure if you are correct or not. I will be glad to answer that. Okay. So these are the variables. These are the variables that we'll be using. You can see, and like I said on the variable view.
Another thing is that
Okay, go ahead.
age, there is commas in age. Decimal number. Age is a decimal number now.
Thank you. That's good. Deogratias, thank you for that. If you look at, I was just going back there. If you look at variable name here, where we have dates, all right, we have date, we have ID number, we have date, and on our date here, our date here is date, not numeric, okay? And that's why we have our date here. Date here, your date here could be date of birth, okay? Could be date of birth here. We have it in numeric here, okay? We have it in date here, not numeric. We have it in date here. And that's why you have various dates here, ranging from what? January 2020. They are all 2020. All the dates here are 2020. So those are issues that I want us to have as an idea before we go into the practical illustration. Remember, what we are interested in knowing is that if all these one, apart from what? ID is just hospital number. There's no way ID number can have influence on cost of health. I hope you know that, everybody.
Yes, sir.
So let's go back to the thank you. Let's go back to the theory. Please always ask questions, especially for today, if in case you have challenges, so that I'll be sure that we are all going along. Can you still see my screen?
Yes, sir.
All right. So the reason why we went back there is that we must, let me increase this. We must be sure that certain variables are confirmed, and that's these three numeric I just highlighted here, and I'm going to put it in red. Why? Look at, there are some assumption here that we must be sure that we have correctly. Otherwise, if you don't confirm this and they are not confirmed, then your solution will be wrong. One, the dependent variable is quantitative. Has that not been confirmed?
Confirmed, sir.
Thank you. Number two, each independent variable is quantitative also, or what we call dichotomous. Now, what we mean by quantitative in the sense that remember where we have nominal, non-nominal variables, that has been confirmed too. That's why it took us to the dependent and independent variable. Both of them are quantitative in nature. And another word is a quantitative what? Dichotomy. In the sense that you have what we call what? Either you call it nominal or what? Or non-nominal. But if you look at your both quantitative and your dependent and independent variable, both of them are what? Both of them are quantitative, and it must be quantitative in nature. Otherwise, you will have trouble. And the third point is your sample size. Your sample size must be large. Your sample size must be large. Now, what is the test of the normal sample size that you should have? It should not be less than 15 rows per what? Per 5 variable. That's why we say 5.15 here, which is 75 cases. And that's about what we have on the screen is about 525 cases in all. Why? The more cases you have, the more success your record will be, the more accurate your result will be. For instance, if your population, you are working within a population of 500, okay, and you are working within a population of 500, and your sample size is now 20, you have issues, except if you are on intervention, whereby sample size does not determine the result. Otherwise, you are supposed to have a very large sample size. I hope that is communicated to everybody. What I'm trying to say here, in essence, is that okay. Let me draw something on the screen maybe that would be better. If your population is this is your population as big as this, then your sample size should be a very good representation, should not be less than what we have in terms of comparison in shapes. All right. Now, if your population is this and your sample size is this, you are going to be in a big trouble, because at the end of the day, your result you get will generate error, and you will not know there's an error, because the sample size will not be a good representation of the population. So all the time, class, your sample size should be good representation of your population in SPSS, so that your results can be good. I don't know if if you can hear me, everybody.
Yes, sir.
I hope we understand.
Okay.
We understand too.
Yes, sir.
The larger the population, the larger the sample size, and that would help us in understanding our results. Okay. Having said that, then let's go ahead. Now, there are some descriptive statistics that you can run, that we have done it before. I just want to remind you. You can run a histogram. If you run histogram on your data, from there you will see missing value. From there you see data that are not supposed to be, that are wrong. It will tell you valid and invalid data. That's number one here. Run histogram. I'm sure we know how to run that under descriptive. We are not going back again. Okay? You can just check our previous videos. You should learn how to do this gradually. Don't move at the speed of others. Move at your own speed. When someone is getting something, don't be so overzealous to also follow. Work on your own speed, and that's why it's a separate lesson. Okay. So if you do that too, you can also run what we call the second one, scatter plot. I also showed us how to do that, where we can have our X and Y axis. We did that a long time ago too. So you can run all this to be sure to inspect that your data is in order. If you run most of these things, you're going to get your result in, like I have on the screen now, your median, standard deviation. Last class we established the fact that the mean, if your mean is small, then it means you have a what? The smaller your mean, the better your result. Always know the meaning of mean, so that you'll be able to use that to explain your data. Okay, so now we want to see few things, that dialog boxes, that we want to understand what they mean before we can use them. Now, on linear regression, if you bring out the button like I have on the screen right now, linear regression is the title we have here, and we have two buttons that are very, very important to us: dependent and independent variable. Your dependent variable is your result, which means you only expect one dialog box, to come out from there, which is the cost of health. And beside the cost of health, we are saying that sex can actually determine how much you spend on health. Some people believe that a male child, you spend more money on female child than a male child. I don't know. That's an assumption. But if you have a data, it's not something you can run. Your data will tell you true or false. Then age determines the cost of health. Those who are smokers, those who are, you can see, alcohol, cigarette, and those who are on exercise. So we have 5 independent variable chasing one dependent variable here. And look at number 1 and number 2. Once you enter this, if you click on your statistics, which is the one by your right, where I have my red ink here. It opens up to linear regression statistics, where we take the types of linear regression that we want to go into, we want to go into. Now we have one by default. By default, we take what we call the estimate. Is usually highlighted or picked or checked, as we have it here. Estimate. Then we talk about at what confidence interval. Remember, at the introduction stage of our SPSS, we mentioned these different intervals in health sciences and in administrative, and we say that for health is just very, very level where we don't joke with what error. Therefore, we expect our error level to be what 0.1. While in administration, we limit our error to be what 0.5. So here we have our confidence interval as what 95%. For others, it could be 99% and others. So you also look at the right hand side where I have label for. These are the types of what? The types of linear regression that we can run. I'm not sure this note covers everything, but if it doesn't, you will have to read more on the model of fit, what we call model of fit, R square change. These are the different results that you can run on SPSS. Model fit, R square change, descriptives. You can also have part and partial correlation, and you can also run collinearity diagnostics. These are the 5 types of linear regression that you can run under that. And when you leave that side, you go to the next one, which is option. On the option side of it, where we have linear regression, options, then we have what we call the stepping method criteria, okay, where we have entry of 0.5, and you also have a removal level. We need to go and read more on this so that we know what is the entry level and what is the removal level in terms of error that we want to, level of error that we want to introduce, so that when you are explaining, you'll be able to explain categorically how this should happen. And this will take us to look at where we have missing values. Missing value says exclude cases likewise, or exclude cases pairwise, or replace a case with what? With mean. Gentlemen and ladies, in missing values, we saw how we can remove a missing value. Let me let you know that there's also a way we may not remove, but we will replace missing value with another value. I only taught you one method of dealing with missing value. There are so many methods of dealing with missing value. Another method is what? Replacing it with another value. Instead of removing it, you generate another value and drop it there. And that will not create an error, and it will not also, you will not be biased in doing that. So the moment you fix all this, the next point is what? You click OK. If you click on paste will not generate the result. But you click on what? You click on OK. So at your own time, please look at some other notes that we have here, as I mentioned earlier for you. Please try and read this note so that you can understand what each of those ink, red numbering and the ink, mean, what they mean to us in SPSS. Now, let's go further for a result that we want to see. In generating an multiple regression result, we have 1, 2, and 3 number here that are very, very important for us to know. The first one here is number one, which we call the B coefficient dictate, which dictates our what? Regression model. And if you look at it, we have a constant here. And our constant here, we have sex, we have age, we have alcohol consumption, etc. It goes on and on. And here we have what we call unstandardized coefficient. And we have standard error that has been introduced. And the next one, after unstandardized, we have standardized coefficient. The unstandardized coefficient is called B. The standardized coefficient is called beta. And the second point there, which is called significant level, SIG. So now, what are we saying here? Each of these variable here, they have contributed certain level to the cost of health. However, not all of them are actually significant to have influenced the cost of health. If you look at the significant level here, let me ask those of you that are good in number, how many, looking at this variable now from sex down, how many of these variables have significant control on the cost of the health of individual from the data that we are pulling out? May I ask that? I will give you the solution, but let me ask if, in case any of us can know. Hello?
Hello, sir.
Yes. I don't know if do you understand the question?
No, sir.
Okay, okay, listen to what I'm saying here. If you look at this class, this is cost of health. And we are saying certain values have influenced or will influence cost of health, such as sex, age. I'm changing them to red. Age, alcohol consumption can influence the cost of health, either by positive or negative. And another one is cigarette, and the values are attached. Okay. Now look at, and lastly we have what, the fifth one, which is exercise, which is this. Now for cost of health, this is the cost of health, overall cost of health that is giving us here. This is for sex, this is for age, this is for alcohol, this is for cigarette, and this is for what? This is for exercise. Now I'm now asking you, if you look at these 5 variables, we have them here: 1, 2, 3, 4, 5. That is their significant level. I'm now saying, how many can you say that these 3 independent variables significantly contribute to the cost of health? If your answer is yes, you will explain. And if your answer is no, you will explain. And I want to know how you arrive at your answer, because everything is actually in the diagram here, but you must know how to read this. These are some of the things that readings that we see when we analyze that we must know how to read. Okay. Anybody? I hope the question is clearer now.
Hello, sir.
Yes.
Okay. If I get it clearly, you want to know, according to the value of the significance, whether those value are significant or not.
Yes.
They are, because their value, as I can see, is less than 0.05.
How many of them are significant?
Five. It's five. 5 of them, yes.
Thank you. Thank you. Eh? Can you come again? Diagratis.
I say all the significant value that I see there,
Okay.
they are lesser than, they are 6, they are lesser than.
Yeah, one is constant. Don't consider the constant value. Don't consider the constant of 0.02. Don't consider the first one. Okay. Yeah, you are correct. You are correct. But I want us to understand how we read this. How do we read this? Now, these are the values, contributions in terms of parameter. These are the significant level. So, for instance, sex in terms of male and female is highly significant because it's actually 0.000. Everything is on zero. Not it's less than what? 0.01. So it is highly significant, meaning that it is valuable. It's going to influence the cost of health. And if you also look at age will also influence the cost of health. How? Look at the value for age here. Okay. Let me see if I can draw something on the screen for you to see. We are still going to know this further, but I just want you to know how we are reading that, so that that's some of the things. Okay, these are the values we are reading, class. These are the values we are reading. These are the values we are reading. These are the values we are reading, one after the other. The first one is what? Sex. Look at sex here. How do you know if sex is significantly contributed to the cost? Because it's less than what? 0.05. So all of them here are less than 0.05. And by the time you are writing your report, that is how you are going to write your report too. So let's go further on that. Since you have been able to see that, let's go down and continue reading. Now
Sorry, sir.
Okay, go ahead.
It means that always constant is not constant, whatever value it may have.
Yes, the constant will always be there. It's not part of the independent variable.
Thank you, sir.
It's always like that in all your regression model. We always create a constant which should not be included as part of your independent variable.
Understood.
Thank you. Now look at this. Say HB coefficient. Now I want us to know what we mean by B coefficient here. B here. You say each B coefficient indicates the average increase in cost associated with a what? 1 unit increase in a predictor. This may appear as a numeric grammar to you, but what we are saying here is that this B variable is an average increase. It is the value of increase to what? To the predictor. And the predictors are what? They are your independent variable. What has this contributed to your independent variable? These are values there. You may not kill yourself so much. Nobody is going to ask you all that. For those of us who are into mathematical numerical analysis, majorly must be able to determine that. But that is the predictor of the increase at which each of these dependent variable. These are the increase by which the independent variable has cost over the what? The cost of the health. This one is 509, this one is 114, this one is 50, this one is 139. And in fact, average hours of exercise is giving us a negative, which means it's running down, it's not significantly, it's significantly increased, but the value of the contribution is what? Is at a negative level. Okay, that's where you know, and the negative runs through from this edge to the last edge. Okay, both the lower and the upper band. Now, how do you write your results? That's the major thing that we would go into. Now, before then, let's look at the significant level here. Say the significant column in our coefficient table contains the two-tailed p-value. All right, remember by now on our ANOVA we have mentioned two-tailed, where we talk about our p-value for each p what? B coefficient. As a general guide, a B coefficient is statistically significant if the significant level is what? Less than 0.05. Which means if your result is less than this, then it is significant. But the moment your result is more than this, then it is not what? It is not significant. And you would have set your hypothesis earlier to determine what to do with your hypothesis, if your hypothesis should be significant or should not be significant. By the time I'm giving us something to work with, I will set a very good question that will be able to put us right on that. So don't be scared on that or what to do. It is not a problem. And the other, like I said, there are 3 results. We've dealt with the first one, the second one. The third one is the beta coefficient, which is number 3 on the table here, beta coefficient. What we have seen the contribution of this, we have seen that of this. Now let's see the contribution of number 3. See, beta coefficient, standardized regression coefficient are useful for comparing the relative strength. You know, the number 1 was to tell us the average contribution of our coefficient. Number 3 is telling us the strength of this contribution to our predictors. See, like so, the 3 strongest, look at this now, the 3 strongest predictor in our coefficient are age, cigarette, exercise. Age, cigarette, exercise. How? Let's go up and see. Age, cigarette, and what? Exercise are the 3 strongest coefficients. Let's see age. Age here we have 3 point what? 0.3 is actually high. 0.3 is high. Age, which one again? Cigarette, consumption of cigarettes, another 0.3, yeah. And lastly, we have minus, okay? We have minus. Now let's see reasons why they are the strongest here. Because we have to report it. Beta coefficients are obtained by standardizing all regression variables into z-score before computing B coefficient. You don't bother yourself about this. Yeah, those of you who are not in the numerical area, if you are just coming here as a user, you don't bother yourself. But basically, we must report why we have our coefficient higher, where we have the highest coefficient here. Even though you want to agree that, okay, you can see they are all 0.0, even though it's not 0 here, but anytime you are interpreting it, they are all what? They are all starting on 0 point. Okay? That's it. They are all on 0 point. And the highest here is 0.3. Highest is 0.3. And after 0.3, may I ask you, class, if you are not asking me why minus is higher than minus 0.28 is higher than plus 0.26. Why is exercise higher than sex? Why is it higher? Why do we have negative higher than positive? Hello, class. Deogratis.
Yes, I believe that when we look into that tire, each part is evaluated by itself. It means we consider from 0, then if I have to go to negative, also negative count as independent. It means the length in negative also is considered as positive in my understanding. Reason why when you have a good number in negative, also I may look it as positive. Or I tend even to ignore signs on that one. Thank you.
All right. Thank you. I don't know if everybody understand what he said. Class, why are we
No,
why,
sir. Oh.
why are we accepting why are we accepting exercise as the third highest value? Why? Because it's actually negative. So why are we taking it? Hello? Is someone speaking to us? Hello? If
Hello.
yeah, okay, Prof.
Hello.
Morning, Prof.
Good morning. Yes.
You're welcome.
Well, can I bring this in and then you confirm if that is right or not?
Please, thank you. Welcome.
Okay. Yes. Since we are looking at regression, the beta, the column, is showing us the contribution of each of those variables to what we are observing in what we are observing in the dependent variable. So age, how much is it contributing? Yes, we have seen that it's significant, but how much is age contributing? That's the where is beta now? 0.322. For average consumption, it's 8.19.
Yes.
Sorry, because I'm using my phone, so
Oh,
I can't see
okay. I will
everything.
increase it now.
Yeah.
Let me increase the screen. Let me increase the screen.
Okay.
Sorry.
So
Yeah.
for average consumption of cigarettes, I guess that's is that 0.192,
Yes.
the beta.
Yes.
And then for average consumption of cigarette per day is 0.311. That of average hours of exercise is negative 0.281.
Yes.
So invariably, from what we have been discussing before, it shows that the more hours that you spend in exercise, the less the costs of the cost of your health care.
Okay.
The inverse relationship. So
Yeah.
it's very significant. It's significant, but it's in the opposite direction. Whereas the others, like age, for example, as you grow older, it means that you might be having more challenges and be having more to pay for the cost of your health.
Thank you so much,
So
Prof.
we didn't notice that
Very,
the
very,
explanation, maybe it makes it easier for them.
very simplify. But let me ask, class. I don't know if you
I want
understand.
to
Okay.
chip in something. I don't know whether it's right or not, but the way I'm thinking is that
Okay. Maybe
exercise.
before you come in, I will, Madam. Before you come in, I will give you the privilege. I just want us to understand what Prof brought in. You can see that each of these independent variables, they vary. If you look at exercise will influence the cost of health. When we say influence, is it going to add to it? Is it going to reduce it? Okay. Look at the average consumption of cigarettes. It's not the level of exercise and cigarette is not going to be the same thing. Look at age, right? The older you are, you know, the older you are, the more likely that your investment on health will increase. We should be able to understand this. We cannot just conclude this based on our logic, but the logic we are bringing in here is based on the data that we just pull out from beta on the screen here now. And that was what I was using some numerical, language earlier, and I said, don't bother yourself about that. It's saying the changes in the predictor, and these are value, but that is the expression, the language that should be okay with us now in terms of age. If we are aging, we're likely to spend more money in the hospital than someone who is just coming up, who has a bright, a good blood and all that. Nothing is changing that. No cigarettes, nothing, no smoking life. Everything is perfect with the lungs and all that. So please, let's understand this very, very clear, so that that will also help us in the explanation of our result, because results are not statutory. There is no casting stone method at which we can explain our result. Our result explanation is dependent on your understanding. And what are you explaining? 1, 2, 3 variables we pull up here is what you will use to support your data. Thank you, Prof. All right, Madam, you can go ahead.
Yes, I just want to maybe look in the direction of the medical aspects, that exercise have something to do even in all the other independent variables too. Like exercise have effects on age and every other variables too. So I think that is why it is very, very significant. I don't know if I'm right.
Yeah, you are. You're right. You're right. Thank you. If you look at all the variables, like we said, all of them are actually significant because it's less than 0.05, meaning that they have a worthy contribution. Either you call it negative or positive contribution to the variable in question. All right, may I ask if we can, our understanding has improved more than before, class? Do you understand this better now?
That calculation of cost below the table.
Come again, Mr. Can you come again?
I see the calculation of cost below the upper table.
Don't
the table that you have.
Don't forget about it. There's no calculation. The calculation here is manual. Okay, what you have here is manual. You don't need it. It's just to tell you what is the total cost, and the total cost is the cost of individual variable here that we have pulled out here. So don't bother yourself. SPSS has done this for you, but for those of you who will want to wonder how did he get it, before now, we used to do this manually before the emergence of SPSS. So that's why you have this calculation on the table. Nobody is going to ask you to do this in your project or ask you to do this in your analysis. Nobody is going to ask you to do this, all right? So don't bother yourself about this. I hope that is clear. It's the same result we have over here that is explanation is, bringing up here to show you how we arrive at those explanations. I hope that is clear.
Okay, sir.
All right. Now let's go on. Before now, last class we did a little of ANOVA, and I gave us something to do to get our result, and our ANOVA and our regression result is closely related, because a lot of models that you'll be pulling together would explain the other one. So if you remember last class, we dealt with number 1, number 2, and number 3, which is what I want us to just to refresh our memory on, because eventually our result is going to come in that level. We have what we call the R result. We have what we call the adjusted R. Now, on a very simple note, if you look at this one single line result, where we have model, how many model? One model, and we have R results, which is 0.629, and we have, after that, we have R squared too, which is 0.395, and we now have adjusted R square, which is 0.390 before we have standard error of estimate. Now let's see the meaning of each of these alphabet, as we should have it in correlation and regression. The R on the number one concept we just saw above denotes multiple correlation coefficient. Anywhere you see that R, it means it deals with what? Multiple. You are talking about multiple correlation coefficient, which is simply in Pearson correlation between the actual score and the predictors or the predicted score after the regression has been made, which means before your result there's a prediction. So it's going to give you the difference between the prediction and the actual score. And the R square, which is usually denoted by R raised to power 2, is simply the square multiple correlation. The square multiple correlation, which is also the proportion of variance in the dependent variable accounted by the entire regression. That is entire regression model. That is the one you consider. We'll look for example where we can put this down very well to the language that will help us. And the R square computed, which is the last one. We have the first one as R adjusted, and the last one is the computed R. The computed R here is what we call sample data, which is over estimate. Is an estimate of the R square of the entire population. We say we therefore prefer to what? To report adjusted R. Adjusted R is what sometimes you will be asked to report, because it is the actual, it's more than the actual, but the reward, the adjusted one, after standard error has been considered. Let's look at how we can pull this out on issue of the data I showed us earlier. Let's see. We'll come back later to talk about other things, but let's see if we can get this result on our multiple regression and see how we can interpret this multiple regression based on what we have on the screen. Permit me to switch back to the data, your SPSS data. Right, can we see this?
Yes, sir.
Yes, sir.
All right, let's go into analysis as we have it. And how do we run a regression model? You go to regression, as we have on the screen. Go to regression, and on the regression analysis here, we have so many types that we can do, so many things that we can do here. Even on the linearity of regression, so many of the concepts of linear that can be handled. So we have the first one is automatic linear modeling. Yeah, we can get there, but before we get into modeling, we need to know how to run a linear regression first before we can talk about modeling of regression. Then there's what we call partial least square of regression. We also have a curve estimation. We have a binary logistic regression. We have a binomial. We have ordinal. We have probability, and so on and so forth. But for today, with this level at which we are starting, let's learn how to do a simple linear regression. Linear means one single line. Okay, then I click. I'm going to remove a lot that I have inserted there earlier. We'll do it together now. And okay, I just did something now. This is likely what you will see. This is likely what you will see when you open this data. And you'll be wondering, how do you determine your variables, your dependent and independent variable from here? How do you know which one is alcohol? How do you know which one is cigarettes? How do you know which one is total cost? What I did was in the aspect of the coding. What we have outside showing here now is the label, is the result of our label, not name. For us to have it understood very well, because we didn't code this, is to go back to name, meaning that the name is what I have here on the ID to the cost. And how do you do that? Just right click anyone here, change it from what? I have it as display variable label. I'm going to change it to what? Display variable name, and I have it back to what is clear to all of us. May I ask if you understand what I just did?
Yes, sir.
Okay.
Repeat it, sir, please.
Okay, what I'm saying here is this. The ID to the cost here is the same thing as I have it here on the name here, right? And beside that, we can have it as this. We can have this as we have it here. We can have it, just a minute please, let me, I will call you back, sir. I'm in an online class, sir. All right. All right, so we have what we have here. I can also switch it to the label, but sometimes you may get it confused as a beginner. I just switch to this now, to the label, by right clicking and changing the name. I just right click again. I want to swap it to what? To the name category here as against label. So I click on display name. You have this data I'm playing with. You could also play with it along the line so that you compare your results to my results, if it's actually valid or not. Okay, I hope that is clear. You asked me to repeat that, and I have repeated
Yes,
that.
sir. Yes, sir. It's very clear.
So for the dependent variable, right now you know that we are dealing with cost of health, and I move the dependent variable there. Okay. Now, how many independent variable are we actually working with? Remember, we are working with 5, isn't it? The ID, the date of birth, and all this may not really. Okay, yes, sex. Yeah, sex has a significant level. So we are picking sex, age, marital state. Okay, 5 of them. We are not picking marital status. We don't need this. Okay, I just pick 5 of this. Exercise, age, alcohol, cigarette, and all that. Then we move it here. Hello, are we together, class?
Yes.
Okay. Now, this is the method. The method here is enter. There are so many methods here. I said we'll go back to that later. We have the enter, we have the stepwise method, we have the remover, we have the backward, we have the forward. These are some of the concepts that we'll still have to learn under regression. I will give us a practical illustration to this. Please remind me after this class. I will give you a practical illustration of a note and how we can use this method. Okay. So for now, just don't select anything. We just want to make our selection from statistics and options, as we explained earlier. So we start with the statistics. By default, this was actually selected, the estimate was selected, but for the confidence level, which is 95%, we select this, as I explained earlier. Then the model fit is what we are looking at, not R-square change. We just want to see if this model fit or not. And at the same time, you can also have your what? The R-square change. which were the two options we explained earlier. Once that is done, you click OK, and you will come to option where we have our probability of our F probability, where we have the stepping method criteria. These are some of the criteria that I will have to give us in notes so that we can understand this. But basically, what we need to know here is that we are looking at exclude cases likewise. So we are looking at exclude, and we are talking about, we have pairwise, we have likewise. But here, in terms of our missing value, we don't have any missing value, so we don't have anything. If you choose not to come here, you are covered because you don't have any missing value. Earlier, before this class, we have seen how we can, one method of removing missing value. And I said in the course of the introduction today that another method is to replace value with a missing value instead of eliminating. The one I taught you was to delete. We can choose not to delete. We can also choose to what? We can choose to include another number in order to remove missing value. We would learn more as we progress. I didn't want to push everything to you so that you don't get confused in the process. So that's why I'm giving you just the basis of what will guide you. At the moment you are done here, just click continue, and let's click OK. Let me change my result at the output for us to see a result there. All right, we have our result. We have our result as we have it here. If you look at, we have model summary of our result, which is a model fit summary where we have our R square, and our adjusted R, which is also reported like and our significant level. And that is the model, that is the fit, one single linear model that tells us that whatever we are doing, if it's correct or not. So at the end of the day, we would go back and see how we can report this linear. And at the same time, you discover that we have this, we have what we have outside also reported here. Coefficient of the contribution of each of the dependent variable over the total healthcare cost, 2,000, and you have them in various ways. We have the beta value, we have the B value, we have the beta, and we have the significant level. So these three too should also be reported in this case. So you will bring out this table alongside with the other table, and you discover that even though a slight variation here, okay, we are not judging. I didn't know how marital status. Did you bring marital status? Marital status is creating a problem there. Marital status is, what can you say about marital status here, class? I don't know if you can read what I have on the screen. Okay, I want to see if I can increase this. Can we see what marital status? I didn't know how this jump into it. What can we say about marital status, class? Is it significant to the cost?
No, sir. It is not significant.
Yeah, that is it. It's not. It's not significant to the cost, and that's why we have it there. Okay. Hello, can you mute your profile, please? So that's obvious from what we have here, because the value of the significance level at the marital status there is higher than what? 0.05. So it's not in any way. So how can you explain this, that this is not? How can you explain this? How can you explain this? Online class, please. Online class. Excuse me, class. Just a minute. Yeah, I'm only calling you. I don't know. I don't know anything. You can call me. All right. I want someone to explain to us how the fact that we have seen that the significant level of marital status is not increasing the cost of health. Can you explain this to a layman? Who can explain this to a layman? I want us to use a layman language. Can you do this? Dear gratis. Anybody? Yes.
Okay, so that that means that the marital status has nothing to do with the cost of health. So it doesn't have any influence. It has nothing to do with it.
Yeah, I know. What does that mean? Does it mean, which means either you are, okay, I didn't want to use my language. I want you to use your own language. I agree with you, but I want a very simple explanation.
So it means that whether one is married or not, it's not going to affect their expenditure.
Exactly, cost the health care cost is not going to alter the health care cost. That's the language I want us to use, because remember I told us that there was a statistical report is not a cast in stone. It's not a cast in stone answer. It should be reported based on your understanding, which is correct. So if that's the only, so
Yes, sir.
okay, yes,
Yes, sir. I was running it there as you are running it.
okay.
And I couldn't find marital status in my own results. I don't know why. Why your own is having marital status.
Okay.
Unfortunately, we picked it up mistakenly somewhere.
Yes, I was also worried. I didn't know I picked it. I was trying to intentionally. I was trying to avoid it. If you saw me when I was speaking it, class, I'm sure you were following me up when I was speaking it. Intentionally, I wanted to avoid it. And I'm not too sure. Maybe it's the analysis I ran earlier before the class that is showing you. Let's cross check again. Thank you, Prof. I assume I did the same as an error. Let's check again and see how.
Sorry, sir. Before we check again, the significance of the constants here is 0.002, while your own is 0.003.
For which contributor now? For which independent variable?
That is the constants.
Oh, constant. Oh, yes, that one has no. It has no. It's not part of the result. It's just a constant.
And sir.
Yes.
I noticed that in my own, I don't know if it is the version of the SPSS I'm using.
Okay.
In my own results, it's usually showing. It's not showing the significance value. It will just show me that the significance is less than 0.01 or less than 0.05.
That's your. It's not okay. Just a minute. Let me. Yeah. Just give me a few minutes.
Okay, sir.
I want to go back to the notes. Okay. Come again with your.
In your analysis, sir.
Yes. Okay. Let me show you what. Let me show you what we have on the screen so that we can compare.
Okay, sir.
We can compare what's. Because what we have on the screen is the same thing we have there. Okay, we had this on the screen, right?
Yes, sir.
Okay, yes. So can you speak to this with respect to what you are getting?
Thank you, sir. See, I got all other values like the one I'm I can see on the screen.
Okay.
But even before now, sir, if I run analysis like that, that significant value,
Yes.
your own is showing the result of the significance, that is 0.01.
Yes.
But mine will show less than 0.01 or less than 0.05. You know this one is in a medical area.
Yes.
Maybe if it is for administration,
Yeah.
it will not show me the value of that significance.
Okay.
It will just show that it's less than 0.05. I don't now know whether it's the
Which version? Which version?
Is the version.
I think this is 26, version
Mine is
26.
27.
Yours is
27, sir.
It's possible. Your version of what you are using can also be the cause of what you are seeing. Because if you go back to the linear regression, you discover that your linearity there on the concept of linearity is 95%. Your interval level is 95%, isn't it?
95, yes.
Yeah,
95. I got all the
which means you have done the right.
I'm seeing it on the screen.
You have
it's
done
just
the right
that
thing.
Significance rule that is showing me less than 0.01.
Even which is still correct, even though it's not giving you exact. It's not giving you bigger value. It's still correct, but you must know how to interpret that before, so that you don't get confused. That's very correct. All right, now
Can I say this too?
Prof,
it's
go
still
ahead.
correct, because even in your write-up, that's the way you are going to express it.
Yes.
If it is less than 0.05, yes, your P less than 0.05. That's the way you present it, if it is significant in your write-up. And once you know the difference between greater than 0.05 and less than 0.05, you'll be able to know this one is significant, this one is not significant.
Okay, I won't need to state the actual value of that significance.
No, you don't. That's like Prof is saying. In some, you don't need to state it. Stating it, you don't need to state it. Just put what we are interested at is not the significant. It's not the value that exactly is the significance of the value.
Okay, sir. Thank you, sir.
Because that is what we are talking about. Variables, multiple independent variables. All of them have contributing factor, but not all of them may be significant. Do you get it? For instance, now we just saw one that jumped into our data, marital status, and we discovered that it's not in any way significant, and we can defend that basically just like the language you use. Either you being married or not does not have effect on the cost of what? The cost of the health. Does not have that, does not alter the cost of your what? Cost of your health and all that. So that is basic.
Dr. Wrighton,
yes, ma'am.
Dr. Wrighton, just a minute. We can see what she's saying right there in the write-up. Since P is, yes, no, you've gone back, up again. Aha, yes. You are, since P is, can you see it? We reject this.
Yes, sir. Yes, ma'am.
Is that not what you are talking about?
Yes.
So that's the way it's expressed. So that should not be a problem.
Okay. Thank you, ma'am.
Yeah. Thank you, Prof. Earlier I was saying that this question may not come in a right way. That maybe the one I will give to you after this class, I will put it in the proper way that I've been trying to get. I always source for simple questions for this class, in case you don't know. It's not just getting textbooks or getting material notes, but I always want to get something very simple, and Prof will still want to come to give us another simple method so that we don't get confused. Okay, there are so many books that you read that you throw SPSS away. It's not that they are wrong, but we need to break it down to the level at the understanding of student. Okay, so before you can reject or accept hypothesis, you must have an assumption of what you expect the result to be. For instance, I can come up with a hypothesis to say that marital status has has an significant level on the cost of what? On the cost of health. And I set it, and at the end of the day, if my hypothesis is wrong, then I can say now, reject what? Please reject my hypothesis, because the answer is what? Is wrong. And that's what we are saying. Since P is less than this, we reject the null hypothesis that we may have set. So let's always get this. So in conclusion, let's see how we can put out our report. And in SPSS, I'm still going to give us something very, very simple to go with, a complete question that will expect us to put our answer rightly. Now, if multiple regression assumption that we must take note when we are running a multiple regression. Number one, we must ensure that we have an independent observation, just like we have seen multiple independent over a dependent variable. Then we must also ensure that we have what we call normality of a data. When you run normality, say the regression residual must be normally distributed in the population. The last two of our classes, I tried to show us a diagram of normality, where we have a diagram from the left to the right passing through the normal curve, and we have the abnormality of also a diagram. And I think I have the two of this showing, for us in the video that was recorded. And so please refer back to that note, and for what, in case you've forgotten what normality of data should be. Then for homoscedasticity, excuse me, homoscedasticity, it has to do with the population variance of residual, which should fluctuate in systematic way. You may need additional notes to this to be able to show the homoscedasticity and the illustration of this practically, which I would get out for us to support this particular assumption. Then linearity. Each predictor must have a linear relation. Now, if I ask us here, what is the linearity of our solution? This is the linearity of the solution here. We are going to write this out in a straight line to conclude this task. And that's let me just bring it out for us. This is our result in a linear form. That's our result in a linear form here. So we're going to bring this, that's the linearity, and I'm sure you saw that earlier at our SPSS output, where we saw how it came out with the ANOVA result of R adjusted R squared and the other concept that we saw. So those three, these assumptions must hold when you are working with multiple regression. So let's see how, and we have also explained earlier that you can use a number of methods to show how to ensure that you are on a very running on a very good level with regression. Now, for linear regression, there are other variables that we have seen on the screen that you will also be exposed to. You can run a regression to show the histogram to ensure that you are running a valid. If you look at the diagram here, this is a normality of a of a data where we have the line running from the center of the beginning of a table of axis to the end, and you discover here that we have both positive and negative showing at equal distance to the diagram. You can run this to ensure that, to find out if you have a valid data or your data is not valid. Another one here is this scatter plot diagram, which I explained earlier too. Your scatter plot diagram here, basic illustration is to ensure that to see if you are working on not missing value now, but to ensure that you don't have outliers. Yeah, outliers. How do you know you have outliers? When your point are not concentrated, they are scattered from the beginning of the where they're supposed to be, concentrated. They are scattered. You cannot draw a simple linear line across that will make any mathematical notation, across and be meaningful to us. So at the end of the day, we need to know how can we write our results out, in an upper format. Upper format means American Psychology Association, and we are working with upper 7 as it were, with the current level of analysis. So if whatever you are doing, you should know, you should be able to write your result out in upper 7. And there's no way you can run away from upper 7 when we have to talk about reporting any of our statistical analysis. So if you look at what we have on the screen right now, how would you put your results? Look at what I have on the screen. Say notes. My R, adjusted R square is this. My N value is this. My P value is this. And what? My confidence interval is also stated. That is what will appear as under your table, but in actual sense, this is the two results that you are bringing out. The first is the linear result. I didn't write this out here. Is this linear result that you are supposed to bring out? You should bring out this linear result. Wish to cover this. Okay. This is the linear result that we must bring out, showing our significant level. We must bring out this linear result and also the other ANOVA results that we have earlier. We must bring both of these out to show that our result, or the contribution of our result over the cost of health. All right. So this is what the linearity of our results. That's what it must show. That's what it must show. Are we stay together, class?
Yes, sir. Yes, sir.
Right. Okay. So I don't know if you have any question. Any question? Let me refer back to the SPSS outputs and show us where we can get how the output was shown earlier and how we can get it, display. All right, this is it. This is the linearity of our result. We have to write our result in a single line this way from this model summary. So the model summary is that we will report the R and the adjusted R, the R square as well as our what? P value. So we are going to report almost the entire line here. We can rewrite this. We'll report this, and at the same time, we also report this result. We also report this. You copy this out, and you can create another table because you don't need the entire construct. Remember, we're only reporting 3: the beta with the B value, the beta, and the significant value are what you are actually reporting. So you don't need everything. You only need 3 columns with your what? With your variables here. How many of these you are generating? 5 of them over what? Over the total cost of health, like we have here. The dependent variable has been reported here, has total care cost for that particular year. So those are the reports the reporting procedures in linear regression or multiple regression as it were, that we must report as requested anytime we are going into such analysis that we will be exposed to. So I'm going to give us something simpler today that is not going to, may not be more than 5 variable. Two, another thing is that when you go into, those of us who are studying, sometimes we look at some variables that are contributing factor to the success of our study. Sometimes money can be a contributing factor. Previous knowledge could be a contributing factor. For instance, a number of us here are into SPSS, and we want to determine the performance evaluation of the students of SPSS. And we are saying that your previous knowledge of your field has significant contribution. So your knowledge of your field could be one of it, age of the student could be one of it, and so many of other factors could be considered part of it. So we want to test if actually this is true or not. And in getting this idea out, it's not just theory. We need to look for data, SPSS data, to be able to run this and come up with what? Results. So I'm going to look for questions that have data, available data from the bank. I will check the data bank we have to pull out something that will help us, and that will be very, very simple enough for us to be able to explain, because we have to explain how this relates and how this does not relate. And I will ask us to list out these simple equation fit for a multiple regression, and also indicate the 3 models of the beta, the B value, and also the significant value, as long with respect to what? Your independent variable. So these are the requests that will come up later between today and tomorrow, and I hope we should be able to answer this. So let me pause here for contribution. Prof, if you have contributions, and also questions.
Just a clarification, so that we don't eventually go and start importing any data. For example, where you were talking about replacing data, missing data. How do they go about that? Is it that they just conjure one figure in their head and replace it?
Okay. Thank you so much. Before now, those of us who have been with us in this class, you discovered that we have learned how to eliminate missing value. Do you still remember, class?
Yes, sir.
And the method we used was elimination. Do you remember?
Yes.
Okay, the system we pick and mark it out. After marking it out, then we say delete. Now, for another method is that we can ask the system to actually factor out similar value in a missing value that the system has generated. And we'll ask for the mean of that value to be used to replace all the missing areas. So it's not you that determines that, but we use the system to generate that value, and it's going to look for the mean of that value to replace all the missing items in a system that the system has identified. So it's not we don't do that arbitrarily. The system will generate that for us appropriately, so that if you do that on your own, you will be biased. But the system has a method of determining the mean of how many missing values are actually determined, and we use that to replace for all other areas as it's appropriate. Okay. I will do a small video to support this. Probably by tomorrow, I will drop this. I will drop the video on how to eliminate missing value using the mean method. Are we clear, class?
This thing has started.
Are we clear?
Okay.
Okay, please.
Wait for that one.
Okay, any other question, please? Or,
Yes,
or
sir.
clarification? All right. Let's take it one after the
Yes,
other.
sir.
Let's take it one after the other.
Okay. Sir, my question is in the area of moderating and mitigating variables.
Good.
I don't know how we are going to run that when we are running our regression, linear or multiple regression. Please, I want you to talk a little bit in that area.
Yeah, I would want to talk in all these areas that you mentioned, but I can't discuss this in abstract level. If you discover all that our practical illustrations that we have been, undergoing or that we have been carrying out, I always come
Yes,
with
sir.
exactly data. I always come with data sets, and because this is not theory, this is absolutely what practical, and it's only through the practical that other people can pick up similar data sets and say, yes, I know how to run this. So there are two things that I can do, and one of it you can help me out. If you have a data that can support this mediating variable, please give me a data set and I will do the video and send it across to us. Or you give me, or you allow me to go and look for a data set that will have a similar question, because it's not just the data set. Your questions must match the data set. Otherwise, you create more confusion than in an attempt to what? Create solution. I hope you understand that, Dr. Misigo.
Yes, sir.
So if
Yes,
you have
sir.
if you have a question with a data set,
Okay.
that would be perfectly fine for me. And if you don't, then you give me time to go and settle down. I need to go and look for questions with similar data set, so that that will help us too.
Okay. For clarification 6, sir.
Yes.
For moderating variables and mediating variables,
Yes.
as in the theory aspect of it, can
Yes.
you please explain the difference just in a layman language?
Okay.
Yes, sir.
All right. The question she's asking may not cut across every field. Deal with moderating variable, and when we are talking about moderating variable, sometimes you talk about different independent variables. There are some that can be controlled. There are some that cannot be controlled. There are some that when you see it coming, you run away from it. There are some that you cannot run away from it, and they will have influence on your results. For instance, an independent variable, you are coming to class and you saw the cloud that is about to rain. For such, you can run away. Either you run away by not going to the class, or you go to the class with a vehicle so that you will not be affected. But however, either you like it or not, one way or the other, if you go with a vehicle, you are not physically affected. Emotionally, some way, one way or the other, you may be affected. So there are independent variables that you can control. There are also independent variables that you cannot control, and there are some that will affect the results. The results will be tampered with by the time the independent variable, moderating variable occur. You will not see them physically appearing, and if you don't remove them, it's going to affect your results. So, but when you see some that are you can moderate, you remove. But what of the ones that you cannot see? What happened? It will create an error impact, and the error will be there. And for such cases, we have what we call effect size. If you have a very large effect size, that may take care of the error. So, but when I have adequate data to be able to explain this to us with respect to analysis, I think I will come up better with that. So when we talk about moderating variable, all of them are actually independent variable. There are things that occur that some you see, some you don't see. The one either you see it or not, it's still going to affect your output. It's going to influence your output at the end of the day. So what you can do is to reduce the effect size on your output. Right. Prof Ma.
Yes.
Right.
I was just going to give an example from the data set that we have used. You know, we were looking at cigarette smoking of the cigarettes as one of the independent variables. But you know, you can still have some other confounding or factors like, look, for example, the type of cigarettes, the number of times, the number that the whoever smokes per day, and even the environment, whether it's a tropical environment or a temperate zone. Those are some factors that can also contribute to the effect that you are seeing. So all of those things, when you are setting up an experiment or a research study, you take them into consideration. And like Dr. Maitomi was saying, there are some that you can control under experimental situation or condition, but there are some that you cannot control, and those ones you need to highlight it and also bring it into the picture when you are drawing your conceptual, this framework, when you are sketching it. Some of those factors you might need to refer to them because they will have an effect on your independent variable, the effect of your independent variable, and you want to be able to quantify it, the effect in your statistical analysis.
Thank you so much, Prof.
I hope it's clearer.
Dr.
Yes,
Misibo,
sir.
is
Yes, Prof.
on the theory?
Thank you, sir.
All right, we'll bring up. I'll get a better. If you have data that I can use, I will get question. Rephrasing the question won't be a problem. But basically, what we need is a data bank to support us in the analysis.
Okay, sir.
So if you get anyone, you can push to me, and if I would definitely look for. Remind me, so that I can do a video on short video, because that is very very key. Those of you in administration, you do
Yes,
such
sir.
analysis a lot. I know you do that a lot. You talk about mediating and all that a lot. So we can run a solution. A solution on that where we see the effect on adjusted R and R square. Very showing.
All right, sir. Thank you, sir.
Yeah, you're welcome. All right. Other questions, contributions, comments, please. We actually still have more time today.
Yes, sir.
All right.
Thank you. I have for maybe 2 questions related to today's class,
Okay.
and another one is like a wish. Okay. Number one, among the independent variables that we considered in today's exercise,
Yes.
we considered the marital status.
Yes.
And at the introduction, you told us that in order to apply multiple linear regression, we have to go with quantitative variables, either for dependent or independent. And I'm asking, why have we considered the marital status, for example, and not, for example, region? If Is it marital status quantitative variable? Why not considering ratio? The second one, we have seen, we discussed multiple linear regression. And we have run a line that we call linear regression. How is non-linear? I wish to get an example related to that one, if possible.
Oh.
And number three is about, I wish, I believe maybe this one is the last class, if we may have a fully example of a case that you may give us on video that solve the entire statistical example, that can be very helpful for us, sir. Thank you so much.
Thank you, Mr. Gratis. Let me start from the last. I can't. It's very challenging to pick one scenario to illustrate all statistical analysis from descriptive to inferential that we started, so that you don't get. There are people. The level of understanding of all of us are not on the same level in this. Numerical understanding is not on the same level in this class. And that's why we are taking the videos one after the other, so that we don't compound things. It will be challenging to pick one video, to pick one class, and solve all the, descriptive and inferential method that we have used. It's going to get people confused, and I won't want to do that. And that's why these videos are in layers. From the introduction, we keep building on it gradually building on the theory. Why didn't we start multiple regression as an inferential statistics as the first class, so that we can have understanding. Our understanding can be built, after a long time. So that's why we have it this level, and I think that will solve that. Or that has solved that. And the videos are actually on the YouTube from day one till today. It's there. It's soon be, nobody can delete that except the author, except I delete it. And we are not intending to do that in any way. Okay. Now, having said that, if I may get you very, very well, we are talking about independent variable. And we are talking about the cost of health. And we are trying to determine which one independent variable has the highest cost on the health status of individual. And we have seen, though, that all of them are contributing factor, but not at the same level. They are all significant, though, but we just discovered that even marital status has nothing to do with it. So you can pick those variables one after the other and say, this particular 0.0 has a very low level, even though it's significant, but it does not have equal contributing factor, as well as what? As well as age, as well as cigarette smoking and all that, or alcohol consumption and all that. So that we can establish from what we have done. I don't know if I have left anything on top.
Are you allowed to also to check for ratio, for example?
To check for ratio? No. Region. What do you mean by region?
Region, yes.
Okay. Region of, can you give us an example? Yes.
Region was one of the variable I saw in our
region.
In our
Region is there. I can show you. Let me show you. Let me just refer to the data. Let me go back to the data set. Yeah, I saw region, but let's look at how valid the region can be in terms of contributing factor. And I want you to judge it yourself if region will be a very good contributing factor in terms of the determinant of the cost of health. So I will want you to answer that question, Mr. Look at region here. Look at region here. And I'm pulling region out now. Now, it's just like having the 6 geopolitical zones we have in Nigeria. This is in America, where we have top 4 cities, north, east, south, and west. So if I will ask you a question, Mr. Deogratis, would it be possible to say that in Nigeria, the 6 your regional settlement in Nigeria here will determine the cost of your health? Is it a hypothesis that one can deduce?
I doubt, because if maybe the food in each region may be different, can't that one affect the?
Yeah, I think you have answered the question. We all doubt it too, and that's why region was not picked, because this is not likely to affect the cost of health of individuals. All right, this is not a strong factor. This is not a strong factor, except, like you said, if there's a particular food that each of these regions are based on that satisfy individuals' way of life, and that is good. For example, if number 1 says is in no smoking state, and number 5 is a smoking state, then we say yes, region can be a contributing factor. But because we don't have those benefit and non-benefit attached to region, then region is not likely. It's not likely. Remember, all our expectations are just assumption, because we need to test it. They are not likely to be a contributing factor to health care of individual.
Thank you.
You're welcome.
My question was to know non-linear regression.
Oh, all right. This is a linear regression. We talk about writing your answer in a straight line. Every other regression beside writing, we have multiple regression, which are not what? Which are non-linear, that you can write your result and your result will not come. If you want me to go mathematically, I would say a linear regression has to do with A plus B plus equals to what? C, where A plus B, A and B has to do with what? Dependent and independent variable. And your C, which is your equality, your C there has to be the what? Has to be the result. Now, this is a linear regression. We're talking about descriptive statistics. Descriptive statistics are actually non-linear regression. They are not in any way regretting anything. They are not regretting. You are not comparing that to multiple variables. Yes, let's use the word multiple variable. Okay.
Okay, thank you.
Yeah.
Sir, I'm having issue with my output. It's different from what you have.
You are having issue with what?
The output from the data that we run.
Okay.
My output is different. It's like I miss a step. I try to do it over and over. I'm still getting different results.
Okay. Can we guide you through where you made the mistakes?
Okay.
Are you here?
Yes, I'm here.
Okay. Can you see the screen?
Yes.
All right. Are you here where we are on the screen right now?
Okay.
Are you here?
Yes.
Okay. Have you selected your dependent and independent variables?
I selected the healthcare cost as a dependent variable.
Okay. And other independent variables?
Yes, sir. That's where I am. I selected that too.
And then you need to take your statistics. You need to take your estimates and your confidence interval.
Confidence interval
and your model fit. We are running a linear model.
Yes.
And R
Yes,
squared
sir.
change. Did you do that?
Oh no.
And beside, all that we have discussed is in a video format. The moment I finish this class, I'm going to terminate the recording, and you will have the video. So you have the rights to run through the videos in case of complexity in understanding certain areas.
Thank you, sir.
Are we together?
Yes, sir. Thank you.
So the moment you select this, you go over to what? Options, and ensure that you have what? including constant in what? In equation on the missing value, where we have exclude cases like list-wise, and
Yes.
click continue, and eventually click on OK. It should have the same result as we have. All right. Thank you so much, gentlemen and ladies. May I ask if further, and let me reiterate that this is an official this is terminating our official meeting of the 6 weeks SPSS that we started a while ago, and I want to thank you. It has been a productive session with all of you. Lots are still going to come in as in form of video. At the moment, I will keep the WhatsApp open. The moment a video solution has been provided based on our request, I will send the link to us. And you can also use the same WhatsApp that we have created to continue to ask questions. Like I said earlier, this is not the end of, it's a long-term relationship created for numerical analysis of data. When I say numerical, we're talking about quantitative analysis. Let it keep coming. We want to see that someday someone here will create a tutorial and will say, I want to pick it up from where we stopped. I want to create a second segment of our analysis. I will be glad to hear that. There are still a number of analyses that we can still do more than where we are stopping. Okay, so let's see how we can run a tutorial, create a tutorial, and also see how we can create a video and help ourselves out. All right, thank you so much for being a wonderful listener and contributor to the growth where we are calling it a day-to-day. And I hope to see you at the top in your various fields of endeavor and practices. Thank you, and bye-bye.
Thank you very much, Dr. Baitondo.
Thank you, ma'am.